Ah, time and work problems. If you've ever prepped for a competitive exam, you know exactly what I'm talking about. They seem so simple on the surface, but man, can they get tricky fast. Well, today we're going to pull back the curtain and make these problems crystal clear. By the end of this, you're going to have a whole arsenal of methods to solve any time and work question they throw at you.
So here's the game plan. We'll kick things off with a classic problem, one you've probably seen before. Then we'll walk through a few different ways to solve it. We're talking percentages, fractions, and even a really slick shortcut using something called LCM. We'll also cover a universal formula for those extra tough questions. And to wrap it all up, we'll figure out which model is the right one for you.
All right, to make this super clear, we're going to stick with one single problem the whole way through. We're going to solve this exact same question using each method, back to back. That way you can really see the pros and cons of each approach and figure out which one just clicks for you. And here it is. I bet this looks familiar. It seems straightforward, but let's be honest. This is the building block for all those trickier questions down the line. So let's break it down together. Trust me, by the time we're finished, solving this kind of problem will feel like second nature.
First up, let's talk about the efficiency percentage model. I actually really like this one because it's so intuitive. It's all about thinking, okay, what percentage of the total job gets done every single day?
So the core idea is pretty simple. If a person takes, let's say, n days to finish a job, their daily efficiency is just 100% divided by n. So for example, if a job takes you 2 days, you're doing 50% of the work each day. Makes sense, right? Simple as that. The process here is a nice, logical three-parter. First, you figure out each person's daily percentage. Step 2, you add them up to see what they can accomplish together in a day. And finally, you just divide 100% by that combined daily number to see how many days it takes to hit the finish line. So let's apply this to our problem. A takes 10 days, so 100 divided by 10, that's an easy 10% per day. B takes 15 days, so 100 divided by 15 gives us that, pesky 6.66% that goes on forever. When they team up, we just add their efforts. 10% plus 6.66% gets them a combined output of 16.66% of the job done every single day. And for the final step, we take the total work, that's 100%, and divide it by their combined daily work of 16.66%. And what does that give us? Boom, exactly 6 days. All right, that's one model down. Remember that number, 6 days.
Now let's look at our second method, the fraction model. This is the classic approach, the one you'll see in a lot of textbooks. And for good reason, it's very direct.
The logic here is almost identical to what we just did, but instead of thinking in percentages, we're just using fractions. So if A takes 10 days to complete a job, that just means in one day, they complete 1/10 of it. And the steps are just as straightforward. You turn their work rates into fractions, you add those fractions together, and then, and this is the key part, you flip the final fraction. You take the reciprocal, and that gives you the total number of days. So for our problem, A's 1-day work is simply 1/10, and B's 1-day work is 1/15. Pretty simple so far. Now for a little bit of math. We add 1/10 and 1/15. Let's use a common denominator, say 30. That gives us 3 over 30 plus 2 over 30, which equals 5 over 30. We can simplify that down to 1/6. So together, they complete 1/6 of the job per day. Now we take the reciprocal of that, flip it upside down, and once again we get our answer, 6 days. Okay, now for what might be my personal favorite, especially when you're under pressure in an exam. This is the LCM model. This method is so clever because it lets you avoid all those annoying fractions and decimals by just thinking about the problem a little differently. So what's really cool about this method is how it reframes everything. Instead of thinking about one whole job, we imagine the job is made up of a bunch of tiny, identical work units. And the genius part is how we pick that number of units. We use the least common multiple, the LCM, of the days each person takes.
Here's the game plan. First, you find the LCM of the given days. That number now represents the total amount of work. Second, you calculate how many of these units each person can produce in one day. Finally, you just divide the total units by their combined daily unit output.
Let's see this in action. The LCM of 10 and 15 is 30. So we're going to pretend the total job is to make 30 widgets. Since A takes 10 days, they must be making 3 widgets per day. B takes 15 days, so they're making 2 widgets per day. Together, their little factory is pumping out 5 widgets every day. So to make 30 widgets in total, 30 divided by 5 gives us, you guessed it, 6 days. See, no fractions, no decimals, just clean, whole numbers. Okay, so far we've handled a pretty simple case. But what happens when problems get more complex? With different numbers of workers, or they work different hours, or do different amounts of work. For that, we need to bring out the big guns. And this is it, the universal formula, often called the MDW formula. What it says is that for any given job, the number of people, or men, times the days they work, divided by the work they complete, is always a constant. This is super powerful because it lets you set two different scenarios equal to each other to solve for any missing piece. Let's quickly break down the variables. M stands for men, but it really just means the number of workers. D is for days, but it could be any unit of time, hours, weeks, you name it. And W is the actual amount of work they got done, like how many trees they cut or how many books they printed. You can even extend this formula to include other things, like hours worked per day. This quote really gets to the core of why this formula works so well. It's just common sense, right? If you have more people, you can do more work. That's a direct relationship. But if you have more people, it'll take you less time to finish a job. That's an inverse relationship. This one little formula elegantly captures both of those ideas at the same time. We have now covered several really powerful methods. So the big question is, which one should you actually use? Well, the best answer really depends on the specific problem and, honestly, on your own personal preference. So let's do a quick recap. The percentage model is fantastic for just getting the concept, but it can get messy with those repeating decimals. The fraction model is the classic, old reliable method, but sometimes the math can slow you down. In the LCM model, that's the superstar for speed, especially in a timed exam, as long as you can get your head around that abstract idea of work units. Knowing all three just makes you incredibly flexible. So we've equipped you with a complete toolkit to tackle these problems from every angle. You've got the conceptual way, the classic way, and the shortcut. The real question now is, which one clicks best with how you think? Practice them all, for sure, but find the one that you can lean on when the clock is ticking.